Okay. Back for more. Welcome. Okay. We're going to be talking today about this notion of methods or functions that we introduced today, and I'm going to use it to show you some very powerful things you can do within AnyLogic that most people don't know about. Very few people know about them, which build on this basic notion that we saw today associated with introducing a function into the model. The basic deal we're dealing with here is that there's great complexity in building up models often, and it can become overwhelming if you're not careful about how you structure the model. And one of the most important ways of managing that complexity is to break things into pieces that are clearly named, that have clear functions. You have a separation of different types of concerns into different pieces, and that allows you to kind of build up a model in a way that's more scalable. Those different pieces can be created by different people. You don't have to look at complexity unless you want to go take a look at how it's implemented. You could simply call it and not worry about the details of exactly how it's implemented. You can modify it at one place instead of many places in the throughout your model. So managing this complexity is key, and we make use of this principle of modularity. We sort of try to build our model out of these pieces, each of which has a well-defined function that we could kind of replace without affecting the others. We can replace just one of them, substitute in a new version of it, and the others will be unaffected. And that's the key to sort of maintaining sanity with large models. You don't want it to be the situation where you modify it at one place and that affects the whole rest of the model. That way lies madness, as Shakespeare said in King Lear. If you tweak one thing here and everything else breaks, you're in real trouble. So you want the model to be built up in a way that's modular, where you have these nice little pieces that can be modified without worrying that they're going to affect the other components. It also allows a divide and conquer strategy where you focus on one thing at a time. We saw that today. We sort of wrote one little piece of it, and we said, someone smart is going to write this other piece. And of course, that was us later, but it allowed us to focus on one thing right now, namely getting a list of people who are at our location. Once we had that, we could pass it to this other thing whose job was to count the number of infectious people in a group. So by dividing things up into pieces, we get benefits from modifying the model. We can test those pieces independently. We can review them independently. It's a more transparent model. We can generally sort of evolve the model with much greater clarity. We can often debug it more quickly as well. The main key to this is something called abstraction. It's the process of sort of describing some general feature like count infectives as something that will need to be done, and to call off to it with all the information it needs. So the parameters here. We can call off to it from different places with different parameters. And we'll call count infectives, maybe with different types of groups. So count infectives in group with different groups. And but all we have to deal with is kind of this abstract notion that it will count the number of infected people in a group. Okay, I think I'll go through lightly on this stuff, but the major thing that we're going to be dealing with is we're going to carve out these functions, and we'll give them different parameters to do their job. Okay, so we define a function, and its job in life is to do something, and we need to give it certain information so it can do its job. I gave the example of a contractor. You can't just bring a contractor and say, do your work. They need to know what work you want them to do. You can't just bring a blank envelope into a post office and toss it at them. They need to know where it's got to go to where it's got to go. People need information to undertake services for others, and so it is with computers. They need these so-called functions we define like count number of infectives in group. It needs information to do its job, namely the group in which we want to count the number of infected people. And confusingly, we call these things we pass to it, the arguments of the function, and we call the things, from the function's perspective, it takes what are called parameters. And unfortunately, it uses the same terminology as AnyLogic's parameters. But we talk at taking a parameter that specifies the group, for example, over which to count the number of infectives. Okay. So we saw some examples of that today. I mean, just to use the example we saw today, if it's not going to give you a terrible fright to see it again, we had here in main, we had this thing that was count infectives in group. It's a function. We define it in AnyLogic as a function. We specify a group. It's a list of persons. Oh gosh, I damaged that. Oh, terrible. Oh my gosh. Okay, list of person. That looks better. Okay, I think we're now in good shape again. Okay, count infectives in group. So here we have a group. It's a list of persons. It returns an integer. That's part of its contract. It'll count the number and return it as an int. And this is the details of how it works. But I don't want to see those details unless I have to. Generally speaking, I don't want to have to see this stuff. Yeah, I'm a software engineer. Yes, if I look at it, I'm totally comfortable with it. But I don't want to see that. It's complex overhead. So what I like to do is I like to carve off these pieces into these functions, and then I can use something like this. I could say, count infectives in this certain group. In which group? The groups of agents who are near me. It allows me, and generally I kind of trust that this count infectives in group is correct, that's correct. And my intention is just, okay, given what it does, that it counts the number of infectives in some group I pass to it, that I'm going to focus my attention, my concerns here are going to be in finding the agents who are near me. Because I know with confidence, once I find that, I can pass it, and it will be a happy camper. Okay? So that's an example of a function. I sort of give it this argument. From its perspective, it takes a thing called a parameter, which is called the group. This is its parameter down here. Notice it's called arguments. I think the technical term for it is parameters, but sometimes we kind of confuse what you pass to it and what you take. In any case, these are the things that it needs to do its job. And they call it group from this perspective. Different people will call it with different groups. We call this function twice. Does anyone remember where we called it? We called it from two places. We needed it. We needed it from home, and we need it similarly in the workplace. And that's much nicer than putting that code, putting the code in at both those places. We have it once defined, we call it twice, maybe in the future we'll call it even more, and then nicely we can then modify it at only one place if we want to change it in the future. Alternatively, maybe we have a function that identifies all people who have been smokers for more than n years, where n is a parameter. It's an argument that we would pass to the function. In different contexts, those who have been smoker for more than 1 year, or for more than 10 years in other contexts. Or we want to count the number of people of a certain sex. We specify what's in a certain group, so we give it the group and we give it the name of the sex we want to look for, and it will count the number of people of that sex. Yes?
Do functions always get defined at the level of naming? Or,
no. No.
So, and if they're defined,
for
example, the level of person, can they be called in other agents or at other...
Yeah, you could...
Can only be called within spaces, within the canvas of space?
No, they can be called from elsewhere, yeah.
The functions are global across...
Yeah, so you could define a function, this is very important. I could define a function that's called, let's go talk about this. Let's take an agent here. We'll take a person, okay? Here's a person. Now, here's a person, and we have different levels of, shedding, right? And we might define a function. So one of the big motivations for functions is trying to mitigate the risk of change. Okay, I so whizzed through a slide on that, but it's a key motivator, the risk of change. By defining things in a function, we lessen the fact that a change is going to need to lead to change, or a change in one place is going to need to lead to changes all throughout the model. We want to make it so our model is robust. So if we change something, the effects are minimal elsewhere in the model. We just change it one place. Imagine if we had this situation where we're this person and we have the state chart, susceptible shedding recovered. I might know in the future that I'm working with someone who's really kind of interested in evolving the state chart more. Maybe they're talking about later putting an asymptomatic versus symptomatic shedding, or they're talking about capturing different levels of shedding, sort of a very, very a dramatic level that occurs during acute infection and then a lesser level. So I know this might be changing. So rather than in my statistics elsewhere in the model asking every time in the statistic, asking infection state chart, are they in the shedding state? I could do that. I could go define statistics, and in fact, they're in this model right now, right? Here's, if I go to main and I go look at population, there's this thing here called count shedding, and I ask, are they in the shedding state? But that's fragile, because maybe later the folks I'm working with, the domain experts, are going to tell me they want to turn this into several things, right? So maybe it would be much more robust to do this. I drag in a new function here. Let's go up to drag in a function here that's called isShedding, okay? Now, why would I do that? I mean, I could always ask this thing here. Well, one thing, it'll be cleaner to call. It'll be less troublesome to call. I'll call it isShedding. Its job in life will be to tell us whether or not it's shedding, and therefore it returns a Boolean. And right now, how's it going to be defined? It's just going to be defined to tell us exactly if they're in that state in the state chart, right? In fact, I could even copy it from this guy here, from main, where we saw those nice statistics. I even had the nice little formula for it, right? Scroll down here, this formula. I can basically copy this formula, right? Now, you may wonder, why in the world would I define this function if that formula does perfectly good job? Well, there's a very good reason, and I'll tell it to you. So here we go. I'm going to return this dot infection state is state active, right? Right now, that's fine. That's great. And I'm going to go over here to main. Here we are in main, and I'm going to go to population, and I'm going to call that function instead. Instead of directly asking this, I'm going to call this function. Okay, so I'm going to replace this with what? What do I replace it with? Item dot is shedding. Now, why in the world would I do that? Well, for one thing, I would argue this is clearer. At least if you know what is means. If you don't want to use is, just, am I shedding or something like that. But is shedding indicates, is it true or not that this person is shedding? So I would argue this is clearer than that long expression. That long expression, you got to know, is state chart, is state active, you got to look at it and piece it through. I don't like looking at that any more than you do. Sure, I know exactly what it means, but it's just burden on my head. If I look at this, I say, oh, that's clean, that's elegant, that's sweet. So here, this would be an improvement from that perspective, but it's also an improvement because later, as I talk to the domain expert, they may really tell me, oh, go modify this to have asymptomatic shedding or symptomatic shedding, or have 3 stages of shedding, different levels of clinical severity of the disease. And I can modify all of those. And where would I change it? I would just change it one place. It might be used many places in this model. Many places in the model would call off to this function. I just change it here, and the rest of the model, as long as it's calling this function, it's fine.
Use it in other agents, other
I could use it in editor agents. I could use it in statistics. I could use it in graphs. I could use it in places in the model where I could use it here in this sort of I could use it associated with, remember that thing in main where it's count infective and group? I could change this to be, this is a great little example. Instead of asking this, now I just do P dot what? Is shedding, right? And now all I have to do is modify it once, and these other things still work. If I changed that state chart before, if I went and changed that state chart, if I had changed the state chart to add 3 shedding states, now it would have broken those places. It would have broken my statistics, and it would have broken that place where I was determining the number of infectious individuals, the count infectious and group. If I had modified my state chart, it would have broken them because all they were looking is whether I'm in this particular state. And now suddenly they'd have to consider 2 other states. I'd have to go back and fix them up here, fix them up there. I might miss some of them. Some of them are still broken and are giving bad statistics or whatever. But here, because they're calling this, I know I just have to modify it here, and the deed is done.
So stylistically, you tend to gather your function.
Yeah.
At main or...
Functions, that's a great question. Functions that have to do with a person, I tend to put in person. Functions that have to do with the workplace, I'd put in workplace. Functions that have to do with the home, I'd put in a home. Functions that have to do with the entire system, I would tend to put, or with large groups of, or with groups of agents, I would tend to put in main. Like count infectives in group, that's not about a particular person. It's about counting the number that are in a group, so I'd put that in main. Does that make sense? Yeah. So, yeah, question. Trent.
So, if I want to call is shedding,
yes,
and I happen to be in workplace,
yeah,
I would refer to it as person.is shedding. Is that correct?
So
I'm
if
calling it from outside person.
Yeah, so like in main,
Yeah.
let's go look at where I'm calling it. Count infective in group. Here. Hey, come on. What I call it on P, each person P. I call it, if I have a person P, maybe I want to call a person, just to be clear about it. They're a person, a reference to a person, so I'll call person.is shedding. I ask them, are you shedding?
That's not any person workspace there. You could call it just my counter. Right? My counter dot is shedding.
Well, this is each person in turn.
That's functionally what it is. The notationally, it's just a counter and a loop.
It's actually not. It's not a counter itself. It's giving me a reference to each person in turn. So the first person gives me maybe to John, a reference to John, and the next person is a reference to Mary.
Right, but it's not the person you have.
It's
Lowercase.
oh yeah, it's lowercase p, and what that means is it's a particular person. Person with a capital P describes personhood, what it means to be a person, personness. And then we have many particular people. They have a particular home, a particular workspace. They're in a particular state here. So we call them instances of person. And what this loop is doing, count infective in group, it's looping through a set of a group and getting individual particular people that are instances of person as a whole. Does that make sense?
It does.
Yeah. Right. Okay. So here we added these functions. We kind of littered them in today. One function layered atop another. Person has several functions in it. Current exposure level, and then is shedding. In this current exposure level was calculating sort of whether based on whether or not they're in this place or this place. Again, now if I change this, I would change it here, and I wouldn't have lots like these other things referring to these directly. It would just refer to this current exposure level, and that's a meaningful concept. Current exposure level. It's kind of it has meaning to it, like in and of itself. And that's what I want to capture with my functions. They want to do something meaningful, something I can express, rather than looking at weird code that's complicated and that it gives me a headache to look at. Instead, I just have the nice name, and I can say, oh, that's just saying whether or not they're shedding. I don't have to reason through all this weird code that's in front of me. Instead, I just say, oh, are they shedding? It's clear. Yeah.
This kind of goes back to the question or the comment that you made about modularity.
Yeah.
I was just trying to work with a model with one of the TAs where we shut off major components of the model and make it work.
Right.
And you got error messages.
Right.
So how do you structure your model so that you can shut components off? Like, could you shut off workplace here and run the model and not have error messages where variables and things are being drawn on that means you can't run it?
So it's a good question.
How do you structure that from the beginning so that you have this modularity that you're talking about? It means you can do components and then go sort of retrospectively ignore a bunch of things.
Yeah. So functions give us some modularity. So modularity in AnyLogic is less than I'd like. I have an issue about this, and we've brought it up with AnyLogic before. We really would like to have models that are modular in the sense that we can take out a component and put in a new component, or take it out altogether and have it still work. And some of the things that Alan and I and Jeff have been talking with AnyLogic about aim to do that, to make it sort of auto reconfigure if you take pieces out or what have you. Right now, it's not so easy in the sense that, like if I went and disabled, so I could go to workplace here and I could say ignore, but it's going to throw a fit. It's going to throw a fit. It's going to say, I don't know what to do. Now, why is it throwing a fit? Look at that. Look at all those things. It's throwing a fit because, among other things, each person has a reference to a workplace, and it's like, I don't know what a workplace is. So you kind of right now have to go disable a bunch of things. So I could go say ignore this one, and I could go say ignore the other, and that would start to work. But it's very imperfect. I mean, you could do it. It would probably take about 5 minutes for me to fix up the model so it doesn't depend at all on workplaces. Not at all.
What you're saying is that you can insert functions or various things like that to reduce the amount of changes that you have. There's no way of structuring it from the beginning that you can actually be truly modular so you can turn some big chunks off.
Right. Not yet. Not yet. I think we're working towards greater modularity. I think we have a long way to go yet. I think there's enough complexity that it puts a premium on reducing what complexity you can control to a minimum. In other words, there's a certain amount that kind of comes with the territory right now. And it's unfortunate. I don't like that. We are evolving our own agent-based modeling language where modularity is front and center part of the whole picture. It's really captured into the design of the language in a very in a quite significant way, and things are encapsulated nicely. And AnyLogic falls short in some degrees in that regards. But so there's a lot of things, if you're working with it, you kind of go with the territory right now. And I wish it weren't so. I wish I could carve certain things out so they could be tested independently, so I could disable all the new features I've added in Snap and see if it still behaves in the old way. All those sort of things would be great. And we're working on them. But there are a lot of things you can control. And as your model grows, those things start to become bigger and bigger and bigger dominant component of the complexity. It's not so much the things that you're baggaged with from AnyLogic. It's actually more and more the things that you have created. You've dug your own hole. And that's what we're trying to avoid, digging our own hole. Does that make sense? And functions are a part of that. Now, this model I showed you yesterday, Dylan's model, that's a particularly exemplary model of because he has all these things divided up into functions. And you could tell he's a software engineer. He's a software engineer, Saskatchewan born and bred and trained under me. And I must say that he's done a fun job. And he's done me proud. So if we got a person here, we have these various charts and so on, all familiar territory, but you start to see functions there, and then up above, you start to see all these named constants, and here, here are all these table functions, all these other functions, get birth weight of newborns in grams, get height of newborns in centimeters. He's got lots of functions, and he's not putting those in there just like creating functions. He's not putting them in there just to be pedantic. He's putting them in there because he, like me, has been burnt way too many times by having to go change things after the fact just because we changed the little thing our state chart represents. Now we have to go fix 10 other things in the model. That's just it grates on you. It's a pain. It's really bad. And so you build these functions and you insulate yourself from it. You have get age, and now you don't have to worry about age, whether age is represented in a state chart in a continuous way by subtracting it, or in a variable. You can handle all those things. You just have something that returns get age as a function, and you just call get age. Everywhere else in the model calls age, and it's up to your business in the internals of a person whether you represent it in a variable or in a state chart or in a continuous way. Does that make sense? And so you can evolve any of those, and the rest of the model still works just like that. Yeah. Thank you. I lapsed into vernacular. So a method is a function of a very particular sort. A method is a function that operates on an object and like an agent. Okay? So let me try to be very concrete about it. I would say if I had a person P, there's Dylan. Dylan, we're praising your model. We're praising your use of functional abstraction in your model.
In which model?
In your GDM model.
Oh, God, you're looking at that. There's so much stuff to it. Why would you use that as an example?
Yeah, I'm moving right along. Yeah, he's built lots of other things too. So why is this? Why do I call it a method too? These things are all functions, and from AnyLogic's perspective, it calls them functions, hence the F. But I would call get age. Suppose I had a person P, called P. There's a reference to John or to Mary or to Sue or what have you. How do I call? So it's some reference to some person. How do I call get age? What would I say? I'd say P dot get age, right? I call it on this person. That's the sign it's a method. We call it P, we're asking P's get age. Because we're asking them, it's a method. A so-called pure function that's not a method would be something like sine. You don't say a person's sine. You would just say sine of 90 degrees, right? Something along those lines, yeah. Anyway, I use method and function kind of interchangeably a lot because most of the functions we deal with here are methods. And the is shedding, that's a method. We call person.isShedding. Does that make sense? Okay. Now, I don't know how much what I'm telling you it just seems like so bizarre. I have no sense of whether these things are making sense that I'm talking about. But carving these things off into functions rather than littering, each of them has some code associated with it. Look at this. Do you want this code to be in 20 different places all throughout your model? get height in centimeters. Do you want every time you need someone's height in centimeters, you just paste in this code? That way lies madness. Later you decide you want to base it not on their adult height but at some other height or whatever, and you end up having to go redefine it in all these different places. So it really helps to divide these off into functions. Okay, so what about functions? Let's talk about these things. So what do functions do? I talked some about parameterization. Right. So these methods, these functions, they might compute a value, compute an age. Maybe it's calculating the current time minus my birth time, and that's how it returns it. Maybe it's looking at a state chart saying, oh, you're in the 0 to 4 age category, or you're in the 45 to 49 age category, and therefore you're such and such years old, or what have you. That's all hidden. The person who calls it doesn't have to know it. So it computes a value. Or it may test some condition. Is shedding? Is water? It tests that. And maybe it's based on the altitude if it's less than 0, less than sea level or whatever. But that's all hidden. The person who calls it just says, is water. They don't want to know anything about how it's calculated. I don't want to know any more than I need to, because the world is complicated enough. I don't want to have to be bothered with all sorts of vague details. Just like every morning, if I were to drive into work every morning, I don't want to know all the details about the current location of the pistons or whatever. That's for someone else to worry about, not for me. I want to know just what details I need to do my job. This function might perform an update on a person, infect a person, simulate change of state, transmit an infection to another. Let's look at the Dillon model. Make pregnant is a function. I want to update visualization. Okay, let's move on. Give birth is a function. That one's also more textured. So there's functions which perform some operation, make them a certain color them a certain color, return a representation, return all the relevant information about them to be printed out or whatever. These are jobs of functions. Okay. Yeah.
Difference between
yes.
a parameter and a constant variable. There's a lot of constant variables up there. I'm just trying to.
Yeah, there are a lot of constants. Yeah, weight. So up here there's constants. Yeah. So this is not a question about functions. It's a question more generally. Why would you have a parameter? Why would you have a constant? Well, certainly a constant will be something like I would imagine if there's established standards for things like the blood glucose level by the oral glucose tolerance test by which someone's considered diabetic, that would be a standard constant. If there's a weight threshold of 4 kilograms for to be considered macrosomic, that would be a constant. That ain't going to be changing. You're not going to be saying, suppose we had a situation where, pi was 4. What would be the consequence for our model?
So this is not that we're assuming to be true.
Yeah, we're assuming to be. It's maybe a yardstick by which you measure things, whether someone's macrosomic or not, or what have you. By contrast, there's things where we might want to change our assumptions about it reasonably, and often we'll make that a parameter because we want the flexibility to be able to change it in our experiments. Does that make sense? Yeah. Okay, sure. Okay, so functions are good things. Here's a bunch of functions. Is current smoker. The count of contacts. The count of smoking contacts. How many of my contacts smoke? Get my smoking initiation hazard coefficient. Get my the sort of diameter of this circle or what have you. Okay. Yeah. Question.
So does AnyLogic automatically establish getters and setters, or do you have to do them yourself?
For like get sex, get income.
If you've got some sort of variable position.
Oh, does it? Yeah, it does actually.
It does.
Now that you mention it, does. Yeah.
Is it parameters or variables that it does automatic getters and setters?
I think it has them for parameters, but let me go check here. Okay. So here we go. Here we go back to the model. Okay, so here's person. I think it does. I actually stand remiss before you. I should use them probably, but I don't. And partly because I don't know that they're very well documented. See here, set home, right? So there's set home, set workplace, right? But I don't see a get workplace.
Now, can you search that file? Can you do a
Sure.
Control F?
Sure. Yeah.
Okay.
Get workplace. No. Get main. Yeah. That's the only gets I see. Yeah. Only setters. Yeah. Yeah. So in common SQL object-oriented programming, we often provide getters and setters for common characteristics of ourselves, so others can get those values without knowing the exact name of the variable involved. In fact, it might not even be stored a variable; it might be calculated, and we can return it. But yeah, AnyLogic doesn't provide for that. Methods often and functions often delegate to each other. We saw that today. I don't know. Were you folks traumatized by that model we built?
A little bit.
Okay.
No, it wasn't that bad.
You
have like quirky bugs, and then you have to stop the
yeah.
bug, and then you keep going, and you can catch up.
Yeah, that's the problem. I know you wish you could press pause for me, right?
Exactly.
Back 30 seconds.
Yeah. Yeah. So maybe even cut off the volume sometimes. Any case, so here, our get visual scale. Do you remember when we did this? We made them bigger. We made them bigger based on how many people were in them or whatever. And I called get occupant count. So often we'll have one method that calls off to another method, one function that calls a different function. And that's to divide our difficulties. We do one thing at a time. This computes, given an occupant count, it computes how big a scale it is. This computes the occupant count. And that's pretty nice. And in fact, yeah, so that computes the current occupant count. And you know, I could have even turned this into a function, which is like get agents here. Get the agents here. Get the agents at this location. That would be that. And then I could call that from here, and I could call it from here because that same calculation is done here. And then if I want to change it from 10, looking for 10 around to looking for 2 around, it would be clear. And look at this. That's quite horrendous, actually. I mean, let's just do that. I mean, horrible. Look at this. So get agents at this location. All right? And what is its job in life going to be? It's going to return a value, okay? And what is it going to return? It's actually going to return a list of people, person, okay? And what list of person is it going to do? It's going to return this thing. But watch this. Oh, it's just beautiful. I mean, don't you hate looking at that? Just make it this dot get agents at this location. That's clear. How many agents are there here, and what's the number of such agents? That size is how many of them are there. That's kind of standard, and you got to kind of get familiar with that. But get agents at location. What is it going to return? Hey, come on, stop that. Okay. Boom. All right. That's what that returns. And then, thing of beauty. Okay, watch this. Gosh. Okay, watch this. I don't want to see that nonsense. Look at all that. I don't want to have to think through that. When I look at it, I just want to call this get agents at location. Now that, ladies and gentlemen, is clear. I get all the agents at this location. I count the number of infectives in that agent, and then I multiply it by a per capita shedding rate. That hits it. And then if I want to change it from 10 to 5 later to judge whether they're at this location, I just replace it here.
Next is what is probably a really question. After list, you've got the greater than or less than things around person.
Yeah.
Does that mean like it's an array or something?
It's in a list of persons. Yeah. Those are called generics. They also go by, in different languages, they go by names type parameterization or templates. But yeah, it means it's a list of these things. But you know, this thing, the fact that it lives in home, it could really apply to workplace as well. It has nothing to do specifically to that.
So just check something.
Yeah.
Interacting.
Yeah.
Somebody wants to use them all. Your assumption about a range is 10.
Yeah.
So I could create a parameter.
Yes.
Which is like a
Yes.
definition of that.
Yes. Yeah.
And put the name of that there.
Darn right.
That like various.
Darn right. Darn right. Darn right. I'd like to avoid putting these constants in here, these magic numbers.
Yeah, it's all visible so they can be changed.
Yeah.
So if I put the practical question, so if I just said that I want to put get agents at this location at main now because I'm gathering things there, and it turns out I want to use that across 10 agents.
Yeah.
Can I just control X and then go to main and control P? What would you say? Like today when we copy and paste something got reset to where it didn't show invisible or something. We copied one of the SD models. Will that do it to that? Like, can you copy and paste functions?
Yeah, you can. Okay. Yeah, you can copy and paste functions. But in this case, the long and short is that we modified a little bit, but yes, you can copy and paste functions, and we often do. Here, we'd modified a little bit so it applies for both workplaces and home. Yeah.
Can you put a parameter and a variable in for 10?
Yeah, we could put a parameter name in for this.
Can you put another function in there?
Oh yeah.
Okay.
Yeah, we could call a function and ask.
So the general rule is you can never open the function.
At a practical level, often the big problem is there's a shortage of functions, not that there's too many. Now, this is a software engineering thing. This is because I'm a software developer. Now, if you go look at code written by other people in my department, they won't always adhere to that. But generally, those who are software developers, software engineers, who make their living traditionally by writing sort of solid code that's maintainable, easily modified, they will use many functions, and they'll use them to sort of encapsulate things neatly. Does that make sense? Okay, so...
It's also really important from a client point of view using it. You made an assumption that in range equals 10.
Right.
They may disagree with that.
That's right.
So I want to be able to do it with them. I have to go into code.
Right.
So I want to
Right.
change the parameter.
Right. So methods are functions and so on. And, okay. Right. Good. I don't know that I need to go into this here because I'm trying to figure out what will be the most valuable thing. I just want to, okay. Sure. Yeah.
Functions can go anywhere, parameters can go anywhere. Your parameters have to live at the level in which they...
Functions, functions can go in all sorts of different places. Parameters you could copy around and so on. Yeah. They do.
Parameter that I use. So everyone knows names,
Yeah, that's to sort of stop madness. It's much of this is to maintain our sanity because we want to know where to go for things.
Yeah, I mean, I'm thinking of the case where you're working with a stakeholder.
Yeah.
And, you know, I might gather all my parameters on the main page.
Yeah.
Put text boxes in them to say, you know, maybe by agent or whatever, but
right.
We can take them and say, look, here are my assumptions.
Right.
You know,
exactly.
AnyLogic is fine with that.
Yes. Yeah. Yeah. It's you can move things around quite readily in that regard. But generally, we try to keep them with the things that they're about. So if we're asking, is shedding, that's about a person. So we kind of try to keep it with a person.
In SD software, we have this concept of a ghost. I think it's in the SD
part. Yeah.
Can you do the same? So you keep your parameters on the model, but I want to create an interface which has a page of assumptions. Can I somehow have a...
Right.
So I've got a parameter person. Can I somehow have a copy of that on this assumptions page? So when I'm interacting with a stakeholder, we can talk about here the key assumptions in the model.
Yeah.
Yeah,
word only so. It's not so. Unfortunately, it's not so neat in that regard. And what this leads to is there, like, and this is a point of tension. I feel really torn about this, and you probably would find it bizarre how torn I feel, and probably many of my other people here do as well. Some of my students, like Dylan, there's a very strong aesthetic sense on these things. So let's suppose we have a parameter. It's about a person, but it's something which is in common between all parameters, among all people we're going to be assuming. Maybe it's mean age at death, or maybe it's the mortality rate per age. Maybe that's something in common between all people that we're going to assume. Okay, those are not. Maybe we want to assume something, a fertility rate that's common to all people in our model. Do we put that in person or do we put it in main? Put it in person, it's kind of attractive because it's about a person, but there's a number of reasons why then you can't vary it easily during experiments. It's trapped in person, so you can't see it from the experiment to change it. And it's parameters in main that you can change from the experiment. Parameters at a person level you can't automatically change. And you could have put a slider at the person level.
But it won't show up in the simulation.
No, it won't show up. It won't show up as a parameter in. So if I had a parameter, if I have a parameter in main, let's take this, count people, right? Then all these experiments see count people, right? But if I have a parameter at the person level, that you don't have a choice over here because it could differ by people, on a per person basis. Their home differs, so why put it here? That makes sense. But the problem is sometimes we have parameters that conceptually apply to all people. We just want one value to use for all people. Where do we make that live? And generally I put that in main, and I dislike it strongly. It really grates on me as a software engineer because I really want to keep it at the person level, just say it's shared between all people. That's what I wish I could do. I wish I could just give one value for the whole population to assume. But it's not to be right now. Yeah. Does that make sense?
Yeah.
You understand the tension there. Okay, I want to talk with you, though, about a few additional things here, which I think could be of real help to you. One is you got to realize when functions call each other, when they call each other, what happens is that one gets called inside of the other, and they form a tall thing we call a stack. It's called the call stack. So one function calls off to another, calls off to another. Let me give you a little example here. So in home, we had, look at this. Oh man. Here we go. Get visual scale, which is called up here, right? This thing was calling get visual scale. Remember that? This thing calls that. What does that visual scale do? Well, it has to do some work. But first, it's gonna call off to this thing before it can complete its work. Calls off to this thing. Guess what this calls? This calls this guy. And then this guy calls off to get agents in range. And it does its one. Who knows what it calls and what it calls. So as they're being called, one is kind of being layered atop the other. And you know, we may call off to, so let's give an example here. So get visual scale calls off to get occupant count. It's running, it then calls off to this. Get occupant count does its work, which involves calling off to this, and then it comes back and get visual scale finishes its work. It adds it to this, etc. So it's kind of like it operates for a while, then it calls off to something else, and then it comes back, right? And these things get layered atop of one another. One gets called to another, and it gets deep. A calls B, calls C, calls D, calls E. And it's no exaggeration to say it might be 20 deep or something. Delegation, 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 delegation. This is called a call stack. And why am I telling you this? Well, I'm telling you this because sometimes, rarely, but not super rarely, it shows up. You see evidence of it. And so, you know, this guy is maybe called this guy, called that guy. And they call one another. And by the way, they don't interfere with one another. They could use the same names for their so-called formal parameters, for the parameters that they take. One could take what they call group, and then another one could take group, and they don't interfere at all. They're totally different references. One called offspring, another calls offspring. Okay, it's called a call stack. Let's yeah.
Is there any way to
Yes. You want to see it? I feel bad making you see it, but yeah, let's see it. Watch this. You see it actually a fair bit? Oh man. Here, I'll go show you a call stack. You want to see the call stack? Okay, do you remember this learning mobility thing? Oh man. Oh, I moved it. I moved it to the here. Give me a sec. Sorry. Okay. Okay. So it's in tutorials 2014. I consolidated our models yesterday. Here we go. Models built in class. Here we are. Learning mobility. This was the model we built yesterday that exhibited dysfunction. Do you remember that? Where it crashed in the most unceremonious way. Do you remember this?
No, yeah.
Remember that? This was Vikram inspired model. And oh, it's not crashing. Okay, there we go. Crash. Right? This is what we call a crash in computer science. It crashed as opposed to it hung, which is where it just stops doing anything. Okay, this is a call stack. You asked to see a call stack? That's a call stack. That is what that is, ladies and gentlemen. And what is it saying? Well, there's a lot of things in here. I don't know exactly what it is, and you don't know exactly what it is, but there's some things okay, so, folks, there was some sort of transition message that got executed. It then executed an action block. Remember that? You could have entry actions or actions associated with a transition. So it's something having to do that's causing problems. It looks like, oh, it entered a state. Okay, so it actually entered a state. And that state, evidently, when you entered it, involves a move to. And that move to, well, it called a bunch of move tos here. And somewhere down here, it was dealing with some sort of arrival time problem. But it's inside the context of a move to. Okay? So it gives you, now this is actually not a particularly great example because sometimes they can be really clear about where the problem lies. But
blue text in parentheses, is that where the problem is?
No, this is actually tells you if you want to see this, if you want to see this code, you can go click on that. It'll actually show you.
Okay. Yeah.
You want to see enter state? You want to see it?
Yeah, but is that the only way you can see it? Is if it makes an error and then it shows you all the connections, the connected related functions?
No, you can get it to tell you. If you want to see it besides that, you could tell it, hey, show it to me at any time. You'll say, you really want to see this? Yeah, I'll show it to you. Here you go. There you go. That's it. It'll show you a call stack. You can get it to print out call stacks for you as you at your leisure. But here, look at this. This is actually, if we click on this, we see it's entering state. The state is the moving state. This is in BAT. Remember BAT? Let's go to BAT. Here. So this is entered the moving state. Okay, it's something having to do with the moving state. And it's something having to do with this particular line. Move to this thing. That's where it's having trouble. It's dealing with that line. Now, that doesn't tell you, this tells you where the failure was, where the problem is manifested. It doesn't tell you where the fault is necessarily, but it tells you where the failure is, which is often starts to point you towards the fault. What's much worse than this is you have no idea where the failure is. You just, it doesn't work, weird things happen, I don't know where the failure is. And ladies and gentlemen, this call stack here, this call stack that you see, it's easy to, you have no idea it's a call stack, it just seems like gobbledygook. But no, it actually is going to tell you basically where the failure occurred. And that's often the first step in asking, well, what's going on? Without that, you might not know, is it a mobility thing, or is it a thing about the infection, or something like that? And this at least allows you to say it's a mobility thing. And you could give this to AnyLogic, and they'll be able to make a lot more sense of it. People like myself, Dylan, Winchell, folks here, this is a major piece of evidence we will use to try to figure out where the problem is in other contexts for code that we have written. Now, we didn't write most of this code. This is AnyLogic's engine code. Some of this stuff is us. Look at this BAT. That's our model. That's our model. So these things get really deep. This calls this, calls this, calls this, calls this. It's almost like turtles all the way down. Just calls, call. Yeah.
How did you deduce it to move time? Considering that's in the middle of the stack. How did you sort of focus on move to?
Well, it's the deepest thing that I can understand. I see something here. It says movement. There's a bunch of things that are handling errors in here, and it's basically inside of this. This is the key point. The fact that this is on the call stack means it's inside. It's trying to deal with it. This is all details about how it is doing a move to. But the fact is, it's during a move to. It's in the middle of doing that it's having problems. That's what that tells me. It's inside of it in the sense that it has problems to avoid. I was going to say to avoid overwhelming. Maybe that ship has sailed. So folks, imagine. So here, get visual scale. Get visual scale calls get occupant count, right? Get occupant count in turn calls get agent set location, does it not? Now imagine if something occurred here. All these things would still be on the call stack. It would say get visual scale. That would be further down that call stack we were looking at. That would be further down here, and then it would say get occupant count, and then it would say it would say the get agents near me, and those would be the things in the stack. So if the agents near me failed, it would tell us, oh, it was inside get occupant that it had called that. So it's handling that.
Stack, the top of the
top.
Okay.
Top. No, it's the top. It's the top of it.
Those are all internal functions.
These are a bunch of them.
So you wouldn't go there and start with your own stuff.
So it's handling a transition. It's entering the state because of that. As part of that entry of the state, it's trying to move to, and it's doing some movement, and then it gets somehow whacked out in the part of doing the movement. And it has some problem with this arrival time. This is a AnyLogic bug. I'm quite confident of that. I mean, it seems to be very clear. It's contrary to their documentation. It's contrary to what I remember working with AnyLogic 6, and I think it's a bug that they'll fix. We're going to make sure that they know about it. But yeah, this is this whole area here. And if you paste this, If you're going to ask them for help with something, you give them this information, and you give them your model, it can help a lot. It can help a lot to sort of help localize what's going on. Yeah.
Will this ever make your model a little more slowly?
No.
Okay.
No. I mean, functions?
Right, with this nested.
No, not in any material way. Back in the late 1960s, it might have really slowed things down some, but these days, not at all. In fact, sometimes it can even speed things up.
Is there any just quick reason you could give for today when we had to reduce the number of agents and things because it was running so slowly?
Why?
That's probably a different scenario.
It was a different scenario, and there were a couple ways to deal with that. I did it in the most pragmatic way. I said, we don't need 1,200 persons. Yeah, you were wondering, why do we have to do that? Well, the basic deal is, big picture, hybrid models that involve SD combined with ABM, where you have SD inside all these agents. They're reasonably expensive, and somewhere in here, and I'm looking for it here. It may be in this version of AnyLogic. It may be out in the entire model. You can actually specify, and actually I'm surprised I'm not coming across it here. You can actually specify the time steps which it uses to solve the differential equations. In other words, to solve the system dynamics models. And those are often the big issue. Is it's solving them, here it is, it's right here. It's solving them in extremely fine time steps. And I probably could have gone and raised those by, 2 orders of magnitude, maybe 3 orders of magnitude, and it would have run just fine, and it would have been vastly faster. But I didn't want to futz with it and so on, so I just said, okay, I'll deal with a smaller number of people and a smaller number of houses and stuff like that. But it's really the fact that by default, it does things on a very, very fine time step that makes it really quite slow when you have a lot of different stocks and flows going on. Does that make sense? Yeah. Okay. Well, we're probably going to have to wait till tomorrow to see the really nifty thing I want to show you. Oh, it's nice. It's beautiful. It's beautiful. But functions are your friend. Functions help tell you where a problem lies. Remember, if everything was just in one big thing, you wouldn't be able to make as much sense of that call stack. The call stack helps you know in what context, because we have functions. Functions help you make a model more manageable, more easily understood, because you have clear names, easier to modify, easier to test, easier to debug. Lots and lots of good things to recommend them with very little cost. Very little cost indeed. I guess I will say that there are 2 special forms of functions that we may look at tomorrow, and you should know about. 2 special forms. Well, 3 special forms I'm going to talk about. First is what they call a static function. Static or static method. This is not something you call on an agent. Most methods we call on an agent. Person P dot is shedding. Something like that. Person P dot is male. Dot get age. Those operate on an agent. But there are some things we don't call that for. We call it instead on the class. We say like person with a capital P. Person dot get maximum age. Or we say capital person P create a new person or something like that. And occasionally you'll see those. Those are called static methods, very confusingly. And I'm trying to think in a case in AnyLogic where you, I know. Well, yeah, we do have one. I don't know if you folks remember it.
Wait, so did you just name the 2, or did you just name 1?
I've named one of the 3. Static methods, and I have some slides on those. Those are ones listed in my slides. You can go read about it in a little bit more detail. Time is running on, so I don't want to spend too much time. But a static method, and an example is if we have an options list, do you remember we had ethnicity dot get values or get values? Do you remember that? Or you said ethnicity dot values? Maybe it was right. Ethnicity dot values. I think that's how you did it. You're calling this method on the class. You're asking the class not an instance of the class, a class itself to list all the possible values of it. And incidentally, I don't know if you've ever wondered why I say person dot infective. I don't know if you've ever wondered about that. Like in a like we asked the state chart, is state active? That's called this infective. It's not something that belongs to it's a constant, but it's not something that belongs to a particular person. It belongs to the person class as a whole. We use the same value to indicate infective, whether different people are infective. So this is actually a static field, a static variable in there. This is one sort of thing. You'll rarely see it, but occasionally you do, and this is the case. Most time you call it on a particular person, but here you call it on the sort of set of ethnicities. And you can define these things. So I don't. In fact, some of these things that we've done here are really basically static methods. I mean, this thing is a static method. It doesn't need to be called on an instance. It count infection and group. That doesn't need to be called on main. By gosh, by golly, that should be a static thing. Can I make it? Come on. Okay, static. Boom. There we go. Now it's happy. Oh man. So that means it doesn't need any information from main. It doesn't need any information from main. All it does is job in life is to be given a group and to count the number of people in it. It doesn't need anything in main to do its job. So it shouldn't be dependent on main. We don't have to have a main to give it. We could just call it, give it its things, it will do its job. It's just like sine. We could give the sine of 90 degrees. It doesn't need to know about an agent. It just does its job. Okay, so that's one sort of special function. I'm surprised again you tolerate me. Okay, a second form of special function we're going to see tomorrow will be really useful for you folks. And this is where you can become virtuosos. Okay, you know what? You don't believe it? No, you can shine in this area compared to people not attending these tutorials. It can help you shine. And it's called a dynamic parameter. And what this does is, and I'm not going to show this to you because I really want there to be time, and we'll do it tomorrow. But the basic idea is it's really useful for performing interventions. You define a dynamic parameter, for example, and it's like a little function, but you pass it in from the experiment. You can tell I'm getting excited if I got up and started to talk about this. So what its job is, it can be given a person. It takes an argument, takes a parameter, and it tells you whether or not that person is eligible for the intervention. So the reason you do this is different experiments could give different functions. So one experiment could say, the people for the intervention are pregnant women. Another one could say, people for my experiment that I want to conduct, for this scenario, people to intervene on are people with more than a certain number of connections. This other one could say, I'm going to intervene on the lowest age group. This other one could say, I'm going to intervene on the second youngest age group and the youngest age group. Each of these scenarios could give a function that you'll then give each person in the population, say, is this person eligible? If so, we'll perform the intervention. And that is the other thing. It's called an action parameter. It's like a dynamic parameter, except instead of returning a value, yes, they're part of the intervention. No, they're not part of the intervention. It performs the action. It performs the intervention. And the beauty is that in a scenario, you could tell it, perform this intervention or perform that intervention. This scenario could say, on pregnant women, lower their contact rate. This other one could, that's not very plausible. Sorry, on pregnant women, enhance, hygienic compliance with respect to, wearing a face mask. This other one, in the youngest age group, keep them home from school. Another one would be, in elderly, quarantine individuals with ILI symptoms, something like that. So basically each scenario could give a function to main that will perform on whom you want to intervene and how you want to intervene on them. And then you just define scenario after scenario for your different interventions. You don't have to modify the model to, go through and only recognize pregnant women or whatever. That's all part of the scenario definition. All it has to do is define a little bit of code for that. It's provided, and it does its job. And tomorrow we will see it as a crown jewel. Well, okay, you've heard that too many times this week. As the crowning achievement of the Java tutorials. We'll get to see how that works.
That'll be the whole crown then.
Yeah, the crown will be complete.
The crowning.
The coronation. Yeah, it'll be complete. The crown will be in all its bejeweled splendor.
So that would allow you to say you've got a population-based intervention.
Yeah.
And you might say, well, we know that this group really isn't complying and doing very well.
Right.
What would the cost and outcomes look like if we excluded it?
Right. Exactly. So you could say for each scenario, intervene in these groups, not those groups, or intervene with this way of intervening versus that one.
Okay, that.
Yeah. So that is a really nifty thing.
Yeah.
And that you could do with functions.
Right.
But you don't want the function to be missing the bus. And I think the bus is getting here soon. So tomorrow we'll resume and we'll see the crown jewel of the week will be presented. Okay? And thank you for tolerating me.
Nate, what do you have planned for this Saturday morning? How's that set up?
Saturday is
Or is it just Saturday all day?
Saturday all day is project work. If by acclamation people ask me to give a tutorial, like to give a little lecture on things, like build a hierarchical model, I'll build it. If people ask me to give a tutorial on big data and models, I'll give it. If you want me to expound on the virtues of on functions, I might